It is a short unit. So if you notice up here, it starts today and Tuesday next week we test. So it is a short unit. It's pretty easy. But that being said, you need to have had your Learn Smarts done by today. Remember I told you this first day of every time that we start, you need to have Learn Smarts done. So if you don't have them done, that's your homework. You got to get them done before next time. And you need to start working on your homework. I've got several that are almost done with their homework. After they listened today, they were able to do the lecture or do what they needed to. So today we're doing the introduction to alkanes. You also picked up your pre-lab for next time. It is one that you have to do out of the book. For the pre-lab, I want you to take the phrase, whatever it is, that you're answering the question of and make it part of the sentence. So you don't rewrite the question, just put it into the sentence that you're answering it with. Okay, next time hopefully we'll finish the lecture on alkanes. Then we have our experiment with the review and then the test. The experiment is very simple. Make sure you read through it so you know what's going on. All right, here we go. Alkanes. These are used in all over everything basically in our lives has an alkane or an alkene or alkyne. And come on. So waxes, nylons, plastics, gasoline, petrochemicals. The cycloalkanes that we'll talk about next time are asphalts, petroleum jelly, cosmetics, medical purposes. Halo groups are with their Teflon, with our silicon polymers that are on our phones. There's lots and lots of different uses for what alkanes are used for in real life. So, know that there's a lot of different uses. Okay, pretty basic. Get a few of them down. Get the main idea. Okay, next one. Alkanes are hydrocarbons that only have single bonds. Okay, there's no rings in a straight alkane or an acyclic alkane. And the general formula for an acyclic is CnH2n plus 2. So if you think every carbon gets 2 hydrogens plus the N2, get an extra one. So that's how that plus 2. They're known as saturated alkanes or saturated fats are part of it that you could get to. And we'll talk about fats later. Okay, this is undecane, which means it's 11 carbons long. We okay to move forward? I tried to highlight things in blue that you needed. Because it's decane, which is 10 plus 1 more. Okay, cyclics, which we'll talk about next time, just have the general formula CN2N plus, try that again, CnH2n. All alkane molecules that end in ANE have single bonds. So they end in ANE. Methane, now this is on the right-hand side. You'll see a column of stuff that says 1 through whatever. Methane is a 1-carbon alkane. There are several different ways we can write it. CH4, we can draw it out, show the structure. We can show it a 3D representation, and we can actually do a ball and stick model. So you need the name methane down underneath carbon 1. 2 carbons is ethane. Again, we can write it several different ways, but we need to be able to know what a 2-carbon alkane is. It's ethane. Propane. It's 3 carbons. Again, we can now show a line diagram which would just be like that, a V. Okay, propane can also be looked at, look like this. It doesn't have to be in a straight line or in the V. It can be in a bend. That bends don't matter. What I worry about is the longest chain. So the longest chain here is 3 carbons. That would make it propane. 4 carbons is butane. Once we get to butane, we now can branch. So butane here has 4 carbons. Isobutane here has 4 carbons. It can be in a straight line, or it can have one off. This is also, besides isobutane, known as methylpropane. Okay, and butane is in butane lighters. Now, up to that point, they have their own special names. So methane, ethane, propane, and butane. Once you get that far, then it sort of follows the math. Okay? So then we get into, well, I guess we'll get into it in a minute. Isomers are different ways I can put things together that have the same number of carbons, same number of hydrogens, maybe they have an oxygen, but I connect them differently. Okay? So here we have 2 carbons, 6 hydrogens, and 1 oxygen, and it makes ethanol. But if I put the oxygen in the center, I now have an ether. And an ether is often used to put people out. Okay? So constitutional isomers are different in the way that atoms are connected to each other. But they have the same molecular formula. Okay? All right. So pentane is where we start going to where the math is. So pentane, pentagon. So now we're looking at shapes. Okay? As the carbons increase, the number of possible isomers that I have can increase also. So pentane in a straight, zigzag line, because remember it'd be 1, 2, 3, 4, 5. It would be the M. Or it can be isopentane, which is 2-methylbutane, or neopentane, which is 2,2-dimethylpropane. These are used a lot in housing, okay, clapboard and cladding, components, pipe insulation, and thermal insulation. Then we go to hexane, heptane, octane, nonane, and decane. It follows the shapes in math, if you know the shapes in math. So after you hit pentane, it just follows the shapes or the names. Hex meaning 6, hept meaning 7, oct meaning 8, 9, non meaning 9, and deca meaning 10. Okay? All right. So, yeah, if you get to sing a song. So the song goes to 1 little, 2 little, 3 little Indians. So if you know the song. Okay, we're going to sing it to that song. I'll do the first verse, and then you guys get to help me with the second verse. Okay? It is simple, you can do it, you can name organic compounds. Learn the song, memorize it, then you're on your way. Now you get to sing with me. We're going to do this 3 times because it's been proven if you do something 3 times, it sticks in your head. And this will help you through the rest of organic chemistry. Ready? 1 is methane, 2 is ethane, 3 is propane, 4 is butane, 5 is pentane, 6 is hexane, 7 heptane, 8 is octane, 9 is nonane, 10 is decane. Now you've got, you can name organic chemicals if you know these 10. Sorry, I forgot the chemicals. So that's 1. We're going to do 2 more times. Ready? 1, 2, 3. 1 is methane, 2 is ethane, 3 is propane, 4 is butane, 5 is pentane, 6 is hexane, 7 heptane, 8 is octane, 9 is nonane, 10 is decane. Now you've got it. You can name organic chemicals if you know these 10. And last time, the big finale. Ready? 1, 2, 3. 1 is methane, 2 is ethane, 3 is propane, 4 is butane, 5 is pentane, 6 is hexane, 7 heptane, 8 is octane, 9 is nonane, 10 is decane. Now you've got it. You can name organic chemicals if you know these 10. Okay, so here we go. We are going to be working with primary, secondary, tertiary, and quaternary carbons, and you need to be able to identify which one it is. Pretty easy. If a carbon's attached to 1 other carbon, it's primary. If it's attached to 2 other carbons, it's secondary. If it's attached to 3 other carbons, it's tertiary. If it's attached to 4 other carbons, it's quaternary. And we symbolize it by putting a degree sign after 1, 2, 3, and 4. Okay, so knowing that, there's a little diagram underneath that. I think I blanked out the 1, 2, 3, and 4 areas. Would you identify which one is a primary, secondary, tertiary, and quaternary carbon? Okay, look up when you've made your decisions and written down what you think it is. We're going to check and see. Do I have any what?
The left arrow
Oh, we'll put that there. Okay, so this should be primary, secondary, tertiary, and quaternary. Pretty easy, right? If it's attached to 1, it's primary, 2, secondary, 3, tertiary, and 4, quaternary. Okay, when we were making our models, and by the way, you are more than welcome anytime we're in this organic group to go and grab the models at any time so that you can make and build the molecules that we're working with. Please don't just build wild, crazy things, okay? Use them to help you learn. So when we were doing that, when we did single bonds, we could actually twist around that bond, okay? And we could actually twist that and it could range. If they were, say, bromine and chlorine, they would actually go into this rotation. That's the way that they would be spatially better suited. Because hydrogens are very small and chlorine and bromine are very large. So they wouldn't like to be down here like this one on the right. They would like to be as far apart as possible because they take more space. Okay? As we look at the rotations, as we get bigger and bigger molecules, remember that it went in that zigzag shape. And that zigzag shape actually was a preferred arrangement. It gives the biggest amount of space to each molecule. If we rotate it, though, we could have got something like this. That's crowded, and when it's crowded, they repel and they force each other back into that zigzag pattern. Okay? Because of that zigzag pattern, we were able to do the line diagrams. Remember the line diagrams? So you should be able to look at a line diagram and be able to bring it right back. Okay, we've got IUPAC. IUPAC is the same thing that we were using with the inorganic chemistry, but they also have organic chemistry where they name it. Compounds. Each compound gets a specific name that's unique and unambiguous. So unambiguous meaning anybody could draw the structure from it. Okay? Unique and unambiguous. Jace, you with me? Okay. Just like dazing off, so I have to make sure. All right, going forward. Okay, most drugs have 3 names. There's a systematic name, which we use the IUPAC, and it would be example 2,4,2-methylpropyl-phenyl propanoic acid. A generic, which would be like ibuprofen. And a trade name, which would be like Motrin or Advil. So each chemical or each drug that we have has these 3 names. So it can be known by many different names. Usually the generic and trade names have nothing to do with the structure. The IUPAC has everything to do with the structure. Okay? When we name an alkane and when we name any organic, we're going to go this method. You're going to have a prefix. What things are attached? You're going to go, what's the largest compound in the chain? That's the parent. And what kind of things, what kind of bonds are in there? That's a suffix. Okay? So we're going to be using this kind of general, put it together. Okay? Now, as we go through this, carbon substitutes are called alkyl groups or alkyl carbides. Or for us, it will be alkanes. To name an alkyl group, change the A and E to YL. So that means it's attached to something if it has a YL. An example of this would be taking an ethane group that's attached to a longer chain and changing the N from ethane to ethyl. Or a methane group, taking off a hydrogen and making it attached to something where that hydrogen was, that makes it a methyl group. We already talked about the ethyl group on the bottom. So changing the N, yes?
Can you go back for a second? Okay.
Sorry. We okay to go forward?
Can you go back one more?
One more? Are we okay to go forward now? Are we still looking? Good to go forward? Okay, so this is what the changes to. So methane becomes methyl, ethane becomes ethyl. You just change the YL. That just means that group is attached to a longer chain. Okay, and it can go on to octyl, nonyl, and decyl. But we probably don't use those right now because we're just starting organic, so we're not going to get to the extremely large molecules. We're going to stay with the smaller ones. Okay, going forward. Here's the steps. And we're going to go through the steps, and then I'm going to have you get out a scratch piece of paper, and we're going to do a whole bunch of different molecules. So the first step is you have to figure out what the longest chain is. So here, the longest chain is 6. Now, I could have gone this way and still got 6 in the longest chain. It does not have to be in a straight line. So what was 6 for the longest chain? What was the name for 6? Hexane. Okay, so hexane would be what 6 would be. So let's take that now. And remember, it doesn't have to be in a straight line. Okay, so any of these would have 6 and they would have hexane. And it's still the same molecule, just drawn a little bit differently. Okay, the second thing is we need to figure out how to number it, because we've got to number these 6. And the key here is we want the lowest numbers possible for anything that's coming off. So which way should I number it? Should I number it like the one on the left or the one on the right? Okay, the one on the left is correct because this gives me the lowest number for my thing coming off. Okay? So that's step 2. I know it says step 1, but it's really step 2. And this would be step 3, but that's okay. Having a little trouble with my numbering system. This right here is a methyl group. It's a 1-carbon group that's attached to a bigger strand. Okay? So it's coming off number 2. So the methyl's coming off number 2, and the longest chain is hexane. So we're going to put all that together. If I have more than one thing coming off, and it's the same one thing, so maybe I have 2 methyl groups coming off at different places, I have to give them their own number, and I have to use prefixes. So it's like a sort of a redundant system. I have to say there's something at 2 and 3, but then I have to say there's di, and then whatever that's at 2 and 3, whether it's a methyl, ethyl, propyl, whatever. Okay? So I have to use, it's sort of redundant, but you do have to do that. Yeah. Okay, so here we have one that would be using the di. Here I have one at 2 and 3 that are methyl groups. So this one I would use di on. Okay? So step 4 is we put all those things together. We put the numbers, the parent, the fixed suffix, everything together. But we have to make sure we alphabetize it. And it's not alphabetized according to the prefix, but according to the main thing. So if I have 2 methyl groups, I'm using M for the methyl, not dimethyl, not the di. Okay? And in front of each of those, there's going to be the numbers of what carbon they're coming off. And they're separated by commas, and numbers and letters are separated by dashes. And that sounds really crazy right now, but we'll get it all together and it won't be so bad. Okay? So if we take this long thing that we were working with at first, here was our methyl group at 2, and our longest chain was 6. So this would be called 2-methylhexane. And I would have a dash between the 2 and the methylhexane. And the methylhexane would be one word. Okay? So I don't use English spacing and stuff like that. It's just a way of naming. If we looked at the other one that we had that had 2 methyl groups, one at 2 and one at 3, then we would go 2, 3, dimethyl, and then hexane. So we would end up with this. Okay? All right, so now, see if you can figure out what this one would be. Go ahead and draw it down, or if it's is it drawn in your notes? Okay, see if you can figure out what this one would be. First of all, look for the longest chain, and I ignore hydrogens. I ignore hydrogens.
So
So I would go like this. No, that's 2 carbons. I'm ignoring the hydrogens, but I'm looking at all the carbons. See if you can figure it out, and then we put the answer up there, and then we'll go through it. And then if you're waiting for us, go ahead and grab out a piece of paper that you can do some more notes on. It's just so much faster to just write them down as we do them. And then I would pick my 3 favorite colors plus yellow of colored pencils. So we're going to use 3 colors. I would not choose black or white. That would not be a good choice. Okay, has everybody got an answer to this? Whoops. Yep. Okay, so the longest chain was octane. Hope you got that. There were things coming off at 2, 5, and 6. Okay. You had a methyl group at 2, a methyl group at 6, and an ethyl group at 5. So this is what you would write. So we're going to break it down, and we're going to go a little bit slower on something else here.